This meeting is being recorded.
All right. Hello, everyone, and welcome to today's webinar. My name is Carlo Bobilas, and I'll be your moderator for this session. Today's session will actually be presented by Senior Security Solutions Architect and Cisco Press author Patrick Lloyd. But before I do hand over the mic, I want to cover a couple housekeeping items. Today's session will be recorded and made available on demand. We'll make sure to provide those details at the end. Also, we'd love to hear from you during today's presentation. So if you are on WebEx and have a question for our speaker, please feel free to send it through the WebEx question and answer panel, where our wonderful panelists are ready to respond. And for those tuning into our live stream, thank you very much for joining in as well. Q&A is limited to those via WebEx. However, we will have a post-event Q&A thread on the Cisco Learning Network where you can post any follow-up questions. So without any further ado, I'd like to kick things off by welcoming our presenter, Patrick. Over to you.
Perfect. And thank you, Carlo, for the warm introduction there. Today's session, we'll be talking a little bit about segmentation. We'll be talking about the enforcement pillar for the Zero Trust Architecture book that about 7 of us wrote recently and came out in August 22. My name is Patrick Lloyd. I'm a senior solutions architect for Cisco Security Services. As I mentioned, I am a co-author on Zero Trust Architectures. I've worked at Cisco for going on about 14 years now, starting as a route switch engineer and route switch architect and moving into security services. As part of my role with Cisco Security Services, I focus on segmentation architectures, smart building architectures, IoT-enabled architectures, and how we employ effective enforcement techniques throughout the architecture and throughout the enterprise to ensure that all of our assets are protected and are subject to requirements as they come on to the network. My previous life working as a DoD contractor doing programming, as well as higher education, running help desks and network engineering teams. As a fun fact about myself, I'm a private pilot. I'm located in Ocala, Florida. So let's talk about the segmentation, challenge of segmentation. So in the previous sessions, what you've heard is about the 5 Zero Trust capabilities. And just to summarize a little bit, when we wrote the Zero Trust Architectures book, we meant for it to be an agnostic look at how to implement Zero Trust into an enterprise based on decades and decades of experience that myself and my fellow authors have. What we found is these 5 capabilities you can utilize regardless of the model for Zero Trust that you plan on employing into either your network or a customer's network. Whether it's NIST, whether it's CISA, DISA, Gartner's model of Zero Trust, Forrester's model of Zero Trust, et cetera, we found that 5 capabilities have to exist in an organization's repertoire before they can ever really succeed with Zero Trust. And that starts with policy and governance. So we heard in previous presentations here that when it comes to policy and governance, we mostly talk about onboarding policies and policies so that we can kind of quell that team dynamic where our networking team really just wants to get devices onto the network, our security team wants to prevent threats from being on the network, and then we have our operations team who's kind of caught in the middle because the operations team is tasked with ensuring that users can get to the applications that make revenue for the overall business. In addition, the policy and governance piece where a device should be onboarded and we should have strict onboarding policies has to be in place so that we ensure that as we move into the identity pillar, we know exactly what we should get from that endpoint. When we talk about what we should be getting from that endpoint, we're focusing on that who is on what device, in what location, at what time, over which medium. And then we have vulnerability management, which is understanding what the vulnerabilities of the network is, but also understanding what the baseline communication of the network looks like as well. And essentially now we get to the enforcement pillar. And what the enforcement pillar is the enforcement pillar is the idea that we should be able to create access policies and describe how two endpoints on the network interact with one another and how they should be able to interact with one another. Whether it's permit deny, whether it's port and protocol, and across our entire portfolio of capabilities at Cisco, we should be able to limit how endpoints interact. And that's what this session is going to mostly talk about. Now, with many of my customers, the four major pieces of feedback that I hear as we get to the enforcement pillar are, first off, I have no idea what's on my network, and I have no idea how to prevent access for anything that may not or should not be on my network. The second piece would be, how do I even know if I'm compromised, and then how do I stop it if I am? Um, a third concern that I hear is my equipment is end of life and it won't let me segment. Kind of a mindset of there are certain features that mean segmentation or are strictly part of the enforcement pillar to me. And then should I start in my DC or should I start in my access? And my goal for this presentation here is to discuss each of these, at least in a roundabout manner, so that you can make some decisions walking away from this presentation. Let's face it, the goal of our network is to identify what our devices are on the network. When it comes to many of our mediums, it's still a large grouping of unknowns, unknown users, unknown devices, unknown use cases on the network. And utilizing some of the identity pieces and the identity pillar, which will feed into the enforcement pillar, our goal is to turn unknowns into knowns and understand what those devices are, and therefore how can we group them so that we can describe a common use case for each grouping of endpoints as they come on to the network. Now, the biggest challenge that we run into is then customers say, okay, now I need to enforce between every single one of these devices. And I need to utilize each of the groups that we saw in the previous slide to describe a use case that says this type of device, this Android phone, this Windows PC, this non-managed mobile device, all interact in this way. What we've found over the course of time is customers who approach it in this way that just say, I'm going to base my enforcement techniques based on only what these devices are, and perhaps what I think they need access to, end up with a customer matrix that looks something like this. When we worked with this customer, and this is an actual customer matrix with data just removed for privacy reasons, they came up with 135 different use cases that they plan to enforce on. The biggest challenge that they ran into is when they handed this to their operations help desk, the challenge of how do I articulate to a level one help desk engineer that a PC with a finance user and a PC with an HR user are treated differently and therefore should have different port, different protocol, or even permit deny access was overwhelming at best. And it just prevented the operations team from pursuing what the definition of success for them was going to be. So we stepped back and we said, let's focus more on security as a journey and not a destination. Not only as we need to enforce everything and prevent everything from communicating to everything else, let's focus on the use cases. How can we broaden out our use cases to 5 to 7 broad use cases to say, here's what a corporate device looks like, here's what a building automation device looks like, here's what a security, or here's what a demo or lab device looks like. And now, how do all those devices have to interact with one another? Because it's quite often that I have the conversation from one of my customers who has mapped this out and says, okay, here's my use cases. I have a red user that has to interact with my red database, but only from one site. They should be prevented from any other site. I have purple users, and those purple users should be able to interact with their database from any site that they come in through. And then, oh, by the way, I have my IT users or my blue users that need to be able to interact with any database, any user, etc. And again, this just gets so complicated. So how do we execute on this and work through the enforcement pillar as it relates to the previous pillars to be able to apply enforcement effectively for our customers? Well, The first is understanding what your journey is. Working through the five pillars means that you're going to get value at each step throughout the mountain that you're climbing to get to policy based segmentation. Of course, your policy based segmentation that you see on the very top of the slide there, about 2/3 of the way across, is kind of the pinnacle of what you're trying to accomplish. We know that we need to prevent some devices from communicating to other devices. But working up through the different steps within our mountain here, we already talked about contextual identity. And we already talked about the idea that I want to understand who is on what device, at which location, which medium are they coming in through, and how are they interacting with devices across my network. Once I understand that, now coming back to our journey, well, now I can establish a consistent onboarding process. My consistent onboarding process can ensure that that identity, that contextual identity of who, what, where, how, and why is essentially ingrained within the network, and in every one of our devices that come onto the network, we can sew that into. And by sewing that into the network and making it the cornerstone of our network, we then have the ability to create enforcement policies based on that identity. Well, once we have that identity locked down, now we need to understand how are these devices interacting with one another across the network. And this comes down to the vulnerability analysis piece, is understanding now the transactional telemetry for how these devices interact. And this means that I want to know the user and the device. I want to know what port they're connected to. I want to know what protocols they're communicating over. I want to know essentially what the baseline of that communication looks like in terms of flags and bytes sent, packets sent, etc. Once I have that, now we can finally start to talk about enforcement. And when we start to talk about enforcement, I come from the Cisco world of 10 years ago, 15 years ago, where we used to scream, TrustSec all the things. And TrustSec is a fantastic technology. Please don't get me wrong. TrustSec is what I've built my career around. But what I've found is there are many limitations with legacy networks. And for customers who in the past have not had the ability to work through their network challenges, to utilize TrustSec everywhere or use it effectively, because they see TrustSec as something similar to an Active Directory group. They see something that they have the ability to associate with this identity and then say this identity interacts with all these other identities in a certain manner. My message here is we've been talking since I was in college, and I won't date myself, but it was over 15 years ago. But we've been talking since I was in college about this concept of the security onion. And the security onion creates what I refer to as trust boundaries. And those trust boundaries can be layered on top of one another to ensure that you have the right enforcement mechanism for the right use case within the organization. This also gives you the ability to little by little work up that mountain. And as we work up that mountain, establish an internal trust boundary where we can map out how devices are interacting, map out a cross-organizational trust boundary. So ensure that as opposed to just one small area, we have a little bit more included in that trust boundary. And then eventually work through external trust boundaries. How do we interact with the outside world? So what does that look like when it comes to practical implementation? Well, when we start to take a look at practical implementation, the first thing you'll see on the very bottom of the security onion here is where I have IDP in orange, your identity provider that's associated with that endpoint. I fully expect that endpoints will have some sort of capability to enforce based on their features and their capabilities what should not be accessing them. And that may be as simple as enabling the username and password capabilities on an IP security camera or an MRI device. By having that internal database or an external reference database, preferably, now we have that ability to say at least someone has to log into that device. Now, that isn't going to protect everything. I think we've all seen brute force attacks that end up trying to exploit a device with every known default credential or every combination within a rainbow table for how this device can be logged into and have credentials or features changed on it to make it a malicious device or an unknown device on the network. But if part of our onboarding process is to change all of our default credentials, if part of our onboarding process is to understand how this device naturally interacts with the rest of the network, we'll hopefully be able to detect that and we'll be able to prevent it with our enforcement mechanism. Well, the next step comes down to utilizing TrustSec. And as I said before, while I'm not a fan of the TrustSec all the things until well into your security journey, and that may be 18, 24, 36 months out, TrustSec is a fantastic mechanism to start to design what your trust boundaries are. And what I'll typically advocate to customers for is utilize TrustSec to create a trust boundary within a VLAN or within a switch. Because within that VLAN or within that switch, it's relatively straightforward to say, I know these devices are plugged into that switch. It's a lab switch, it's a production switch somewhere that I can have a runner go and look at it and say, let me look at what is connected here if I can't actively identify these devices. Well, now within that VLAN or that switch, I can say, as I communicate across that VLAN or switch, now I can create policies that pertain to only those identities and won't affect the rest of the network. We're not trying to boil the ocean. We're minimizing where that enforcement technique is being used to one small area. We can do that across multiple switches without those switches ever needing to have the same policy. But what I do advocate for is utilize the same identity criteria across each of those switches. So as we create our use cases or we create our TrustSec tags, enclaves, whatever you want to refer to them as, keep it within the 5 to 7 quantity to ensure that we know how these devices interact with one another and it's consistent across our entire organization. Because of course the next step beyond what our minimal trust boundaries are here is we know that we're going to want to prevent some trust boundaries or some groups of devices from interacting with one another, and we may use another mechanism as part of that trust boundary, that extended layer 3 trust boundary, for example, from communicating. This may include the use of a dynamic VLAN allocation, for example, the ability within ICE for us to say this endpoint authenticated, I have its identity, I know what it is, and now let me put it onto its proper VLAN, and then let me enforce between these two trust boundaries that I have TrustSec within. I may enforce between them on a firewall, or I may just not route that VLAN, or I may use a downloadable ACL. And that downloadable ACL may say, hey, these two groups of devices or these two trust boundaries may not be able to interact with one another in certain ways, shapes, and forms. And we've worked with a number of hospitals, for example, who are really concerned about malware outbreaks. So what they've done is exactly the approach that we're using here, where they say, I'm going to start with my layer 3 trust boundary. I'm going to say none of my hospitals need to interact with one another. All they need to interact with is my centralized compute and storage that sits in a data center. So I'm going to utilize downloadable ACLs for all of my endpoints to say, you can communicate within your own subnet or the subnets that exist within this site. You don't need to interact with any of the other hospital subnets. Now, the next step beyond that would be to then take that hospital, that internal trust boundary, and determine how devices need to interact there so that you're layering a TrustSec tag and a downloadable ACL on top of one another to utilize them as two separate trust boundaries within the same enforcement mechanism. Eventually, our goal is going to be to unify our trust boundaries. Now, that's going to take some work. For many organizations, this capability to unify that trust boundary means that you've enforced that trust boundary within that small area. You've expanded out a little bit. So you start with a VLAN, you move into a hospital. Now you go across 2 hospitals within the same site the same campus, the same geographical area. Or it's two offices or branches of a financial that we know we can apply the same policies, or we can unify those policies to ensure that we can enforce between them. Of course, between these two sites in this trust boundary and some other trust boundary, same thing. We may be using some other mechanism to say, allow for this communication or don't allow for this communication. The implication here as well is your trust boundary also has to allow for traversal over the mediums that you have that have the ability to relay that trust boundary between the unified sites that you're putting into a singular trust boundary. If we're talking about Cisco TrustSec, that means that you need some sort of SD-WAN, DMVPN, GetVPN, IPsec VPN, SDA fabric, SD-WAN fabric, or security exchange protocol to allow for those tags to be relayed between the two sites that you see at the bottom of the slide and traverse over that WAN. If you don't have that, that's the next area to focus, is enabling that capability to unify that trust boundary or choosing the correct trust boundary that allows for unification across those sites. Now, as I mentioned, there are a number of ways that we can utilize different aspects of the Cisco portfolio to create an enforcement technique in a layered manner. I've already talked about TrustSec tags. And for those unfamiliar with TrustSec tags, a TrustSec tag is a 16-bit identifier that sits inside of the frame header that needs to then be stripped and reapplied each time a frame traverses from one layer 3 device to another layer 3 device. But this allows us the capability to say two devices within the same VLAN on adjacent ports, I can prevent from communicating because I'm controlling them at the frame layer. In addition, we can use the dynamic VLANs that I talked about before, where those dynamic VLANs are allocated from ICE and then enforced upstream at some sort of enforcement device. Our downloadable ACL capability gives us the ability to form a layer 3 trust boundary between two VLANs, two subnets, two sites, however we want to classify those devices. We can utilize firewalls. By no means am I advocating for getting rid of all your firewalls and bringing everything down to the switch. However, I have worked with customers who don't base their enforcement techniques on identity, and they're a managed services provider. So now their users who travel between any one of their sites at any given time have to be identified, or without identity, they have to allow for every one of them to access every one of their managed service customers, which made for approximately 350,000 lines on each one of their firewalls at each site. By pulling all of that enforcement capabilities down to the access layer and applying identity based on it, we are able to cut those number of firewall rules in third. In addition, we also have our DNS filtering capabilities. With Cisco Secure Access, we have the ability to utilize the umbrella cloud, the over 1 billion DNS requests that we get on any given day, and give us that ability to filter out what access external to the site an endpoint interacts with or can interact with. And that could be based on business category, or that could be based on content category. And then finally, secure workload is how we do segmentation in the data center. Whereas in the campus, we would utilize something like secure network analytics, and we would understand how these devices interact with one another and build out a map for how these devices interact and form those policies in the campus with TrustSec, with VLANs, with downloadable ACLs, or even with firewalls. Secure workload has the ability to place an agent onto endpoints or onto workloads in the data center that gives us that same visibility and gives us the ability to modify their IP tables capabilities and how those devices are able to interact with one another locally on that virtual workload or physical workload. Now, the next question that my customers typically ask me is, okay, where do I start? I'm typically a really big advocate for starting on the wired network. Wired is still the Wild West. We've been talking for years about wired being kind of our fallback network. We went through a transition decades ago where we said the wireless network, you're going to have to authenticate onto it, either with a pre-shared key or some sort of shared identity. Oh, and by the way, if you can't get on there, move over to the wired network because the wired network doesn't have any of these things. So now we left wired wide open for anyone to walk into and plug into. And then we started using things like sticky MAC or a limited number of MAC addresses that were allowed on that switch. But that became operationally intensive when we had the maximum number of MACs on there, and then we end of life the devices that were connected to the wired network. So we started to remove some of those features as well. They were also static. They weren't dynamic to give us that ability to say, based on the identity and the information that I get from this user or from this endpoint, I'm going to apply a policy to it accordingly. So now, when we talk about wired, I typically advocate for utilizing wired as the area that you start. And I think that's come across with many of my previous slides here. Utilize that VLAN, that switch, that site as that trust boundary. We want to discover what the devices are on there. And typically that's going to utilize radius. And in the Cisco world, it's going to be identity services engine. We're going to classify those devices and we're going to understand what they are. And we're going to apply broad enforcement techniques to start off with. It may just be permit deny. Your enforcement technique, essentially preventing devices that shouldn't be on your network, is a step in the right direction. And it does provide value and the ability to relay up through management and through the board of directors that based on our regulatory requirements, we are able to prevent devices on the network dynamically based on identity. And then if they start to no longer be needed on the network or start to misbehave, we can send a change of authorization to kick it off of the network and prevent it from getting back on. Now, typically we'll start with that permit deny and we'll move into the VLAN, downloadable ACL, and then SGT approach to enforcement. As I mentioned, as you get to the SGT enforcement, I don't recommend any more than 5 to 7 tags. Now, I've had plenty of customers come up to me after these workshops and say, okay, how many is too many tags? Well, the question really comes down to what can you operationalize? TrustSec can handle 65,535 tags just based on that 16-bit identifier in the frame. But if your operations team is not familiar with TrustSec and isn't ready to operationalize a new enforcement mechanism on the network that doesn't differentiate in any significant amount of detail how two devices need to interact, we're going to get into operational concerns. And it's only going to put a bad taste in everyone's mouth as you start to move through your enforcement journey. Now, my recommendation is do unified categories across trust boundaries whenever possible to minimize permutations. And what that means is a corporate device typically has a soft phone on it. I'm utilizing my PC as my computer audio right now. If I have to interact with a physical phone on the network, I'm going to want to make sure that I don't have to create a downloadable ACL or a security group tag that allows for ports 32,000 all the way through 65,535. What I'm typically going to do is I'm going to take my voice over IP devices, I'm going to take my PCs, I'm going to put them into one category called corporate devices. Now, the next step is up to you. What is your use case that you're looking to accomplish within your enforcement journey? With one customer I worked with, they said, hey, our regulatory team wants us to ensure that PCs and printers never directly interact. Our printers are older. They're the old V1 such and such printers that didn't have an active supplicant, who weren't able to actively prevent interaction with something that wasn't supposed to interact with them. So what we want to do is we want to ensure that a PC is able to talk to a print server, and that print server is able to talk to a printer. And only in that one direction, through a centralized control mechanism, are those PCs able to interact with those printers. Now, of course, at some time in the future, they may collapse that print server and that printer into the corporate devices and utilize the capability to just ensure that those PCs are only able to communicate on the port that goes to the print server and prevent that PC to printer interaction. But this is what I'm talking about when it comes to permutations across trust boundaries. Understanding your grouping of devices and ensuring that that grouping of devices can interact seamlessly within it with minimal restrictions, has a little bit more restriction interacting across trust boundaries, but it gives you the ability to control granularly how trust boundaries and cross trust boundaries interact with one another. For wireless, we've been utilizing wireless, as I said, for years now. We authenticate in some way, shape, or form, a pre-shared key, a IPSK, or even identity. And we see a lot of customers moving towards identity and enforcement based on identity on wireless a lot more because of that effort that we've already made to prevent those devices from getting onto the network if they shouldn't be there. But a lot of times the question comes down to, well, how do I use TrustSec effectively on wireless? And you absolutely can. And the TrustSec capabilities of wireless are most powerful when it's wireless interacting with wired, interacting across essentially trust boundaries that you're creating based on medium. But within wireless itself, for years now, we've been using peer-to-peer blocking as kind of that prevention of devices interacting with one another. So we don't necessarily need TrustSec, or we don't need granular enforcement techniques strictly on the wireless to prevent that peer-to-peer interaction unless we have that peer-to-peer blocking action enabled. As we start to prevent access from wireless to wired and we utilize downloadable ACLs, well, downloadable ACLs are a fantastic way to prevent that interaction or prevent that communication. But one big challenge that we run into is the same thing as the firewall challenge that I ran into earlier or described earlier, is our downloadable ACLs start to grow based on all the permutations that we have between wireless devices, wired devices, or remote access devices. As downloadable ACLs grow beyond 30 lines, that's when we start to kind of consider what is our trust boundary, what are our use cases, and is there a better enforcement mechanism that we can utilize between those trust boundaries, such as a TrustSec tag. Within the data center, I think I already mentioned, secure workload is very much our ability to discover workloads and understand peer interactions. We block same thing as wired in small segments as we become comfortable with understanding how these devices interact with one another. We know that within many of our data center tiers or segments, it's going to be a little bit more welcome to prevent certain devices from interacting with one another, especially in high risk areas. So we take those areas, especially where we have what I'd refer to as allies in our technology areas, to say, let's understand what the peer interaction is. Let's enforce on a permit deny basis, and then move towards a port and protocol basis as we can continue to kind of flesh out what those communications look like. For remote access, I always find it interesting in the technology world how we go, as a pendulum does, back and forth between two dichotomous ideas. For example, we've been utilizing thin clients for years. Previous to that, we were using mainframes and thick clients. Little by little, we're moving back towards the thick client preference, which means that we now have devices coming in over remote access with a full PC that can then gain access either through a proxy or through a DNS filtering capability. With secure access, we have the ability to see over 1 billion DNS requests, as I mentioned earlier. But what we want to also do is we want to understand how are these devices interacting with the external network based on identity once again. We'll enforce based on identity and understanding what those interactions look like. When I say based on identity, that implies a need for centralized authentication for remote access, which may mean you utilize your remote access head end and point it at an identity provider, such as Identity Services Engine. Identity Services Engine will therefore have the ability to push down a downloadable ACL based on the criteria that you create within your use cases. This user came in on this device over remote access and therefore gets these downloadable ACLs. In addition, we may utilize that centralized authorization capability to block DNS to anything except for Umbrella, for example, and only allow for DNS requests through 208.67.222.222. We're more and more starting to see, back on that pendulum topic, firewalls be brought out of the data center and being brought back to the local sites again based on direct internet access. The movement of our policies from the movement of our internet connection, as opposed to being centralized through some sort of MPLS, some sort of head end or shared fabric, to now utilizing consumer-based internet connectivity means that we now need to protect those sites as they go directly out to the internet. And what we're starting to see is a use of firewalls for that. Those firewalls, same thing, can be utilized to apply filtering capabilities to what traffic can leave the site, as well as ensure that DNS and some of our other critical resources that help us as part of our enforcement journey are enforced. Now, when we talk about how long does something like this take, we talked about the mountain climber slide at the very beginning. And essentially, when we take a look at a site, in this timeline that I have here, we're talking about 12 to 18 months. The 12 to 18-month timeline assumes that you're able to utilize and collaborate across teams, across those 5 capabilities to apply this on a site-by-site basis or trust boundary by trust boundary basis. By utilizing that capability to apply this on a trust boundary basis, we can now utilize one site, one VLAN, one switch to apply all of these capabilities. But then when we relay that message to our management, senior management, executive management, or board, on the bottom of this slide, you're going to see here's what the wins are that we're getting at each step of the process. We're creating a consistent onboarding process. That consistent onboarding process ensures that we understand what every one of our authorized devices should be relaying to the network or providing to the network to gain access. With many of our large financial customers, they're seeing contracts that require this of them as they start to enter into peer-to-peer tunnel or business-to-business communications with others, that the contractual language does state that you must understand who is using what device on the network at any given time, with the ability to prevent them from accessing critical resources. In addition, we have other milestones such as minimizing manual overhead, minimizing our operational costs by dynamically allocating where that VLAN should have access or what VLAN it should be on, beginning to segment internal devices from one another, managing external threat analysis and understanding external threat analysis based on where your traffic is going to out on the network, and utilizing that DNS intelligence to say, these devices are or are not able to communicate with this malware site that was spun up 30 minutes ago, being hosted out of a country not conducive to effective business. And then we start to segment cross-organizationally. Now, when I put this on the screen, typically my customers say, man, it's going to take me 12 months or 18 months to get to any sort of enforcement for just one site? Really? Well, no, because what I fully expect is as you start to move down that contextual identity path and you start to get to the point of being able to enforce within a trust boundary, you're going to start applying that enforcement capability to another site and utilize that same or similar trust boundary and lessons learned in kind of a 75-25 split. That I should have a bunch of lessons learned and a bunch of reused devices across my entire organization, whereas 25% of those devices per site will probably be unique to that site. And now I need to start the process over again to understand what these devices are, especially if they didn't go through the onboarding process. Now, I would be remiss as part of my presentation if I didn't mention that this is what I do on a daily basis. As part of the Cisco services portfolio of products, we have the ability to work with our customers either from a technology agnostic standpoint or from a technology specific standpoint and say, what do you have out on your network? What are your use cases? Why are those use cases uh, why are those use cases what they are? What is driving them from a regulatory and internal standpoint, et cetera? And then work with you to plan through how do you utilize the capabilities that you have right now effectively in terms of your products and therefore abilities to create trust boundaries? How do we build that out and integrate that into your current processes and your current products that you have on the network? And we can even manage these products for you. We're working on multiple very large, what we refer to as transformational deals within Cisco services, where Cisco managed services is part of that implementation and is able to do the add, change, remove capabilities for the customer when it comes to this overall technology and the network devices through which the technologies run through. As part of this process, what we do is we help you discover and classify what your devices are out on the network. With our proprietary tools, we have the ability to pull from products such as StealthWatch, your IP address management system, identity services engine, secure workload, CyberVision, your configuration management database, et cetera, and aggregate this all together to say, we know that these users are interacting with these other users on these ports and these protocols in a simple spreadsheet, and therefore, this is what our enforcement technique or enforcement policy should be. The resulting matrix for many of my customers looks something like this, where we minimize the number of permutations to that 5 to 7. In this case, it's 5. But now we can understand now, how do these corporate management devices interact with one another? How do print services interact with one another? Guest is typically going to be denied from anything corporate, anything building management system, but IT may still need to be able to communicate to it for support purposes. And then IT is always going to have typically the largest amount of capabilities out on the network and permissions out on the network because they're part of our enforcement technique to ensure that enforcement is successful or can be overcome or lessons learned injected back into the previous capabilities to ensure our enforcement techniques are the most effective for our customers. With that, thank you everybody for attending this session. I'll be here to answer questions both in the Q&A panel as well as Carla. I don't know if we're doing any live questions, but happy to kind of answer anything there as well.
Awesome. Thank you very much, Patrick. Great presentation. So as Patrick mentioned, if you have a question, feel free to go ahead and post it into the Q&A panel where we can go ahead and answer it live. So let's go take a look. A couple questions came in early on during the session. Maybe you can answer to
Sure.
that first.
Yep. So one question was, any example or use case where no traditional WAN connectivity, and I'm assuming that means that traditional WAN connectivity, everything is direct internet access. And I think I addressed that later on in the deck after this was asked. But essentially, if there's no traditional WAN connectivity, but you still have access to some sort of identity-based understanding of who is on what device in what location at what time over what medium and how they interact with other resources, you can utilize something like identity services for that enforcement capability. More and more, we're starting to see that direct internet access capability with identity services engine hosted in the cloud, for example. So having some sort of direct connect or express route to the Azure cloud, the AWS cloud, et cetera. And we should be able to utilize that identifying information to then push down a policy to those endpoints. And then as those devices kind of interact with one another within the site, you contain the enforcement technique within the site.
Awesome. Thank you very much.
Um,
Sorry,
let's
go ahead.
see. Sure. So you said the use of TrustSec first and then DACL, but in the other slide, it says when ACL goes over more than, it was 30 lines, then use TrustSec. It really comes down to what your use case is. So the biggest challenge that I run into is I have to describe to an audience such as yourselves with 165, 170 different companies, different use cases, different capabilities. What are the different abilities that we have across our enforcement techniques? So my general recommendation is within a VLAN, within a site, within a switch, utilize TrustSec where you can, utilize downloadable ACLs where they are the most powerful for your use case. Downloadable ACLs are typically going to be a layer 3 trust boundary. TrustSec is typically going to be a layer 2 trust boundary until you can kind of combine the two of them by understanding what the full interaction across your entire network looks like.
Awesome. And it looks like some questions did come into the chat. Would you like me to read those out loud to you, Patrick? Or
Sure, let me go through here real
sure.
quick. So um, what enforcement techniques did you recommend to protect the user's credit card information for e-commerce? So typically your enforcement mechanisms there are going to be based on data loss prevention. Data loss prevention is built into our IPS systems, which are going to be part of our firewall. It could be part of our SSE system. Within Cisco Secure Access, we do have DLP and pattern detection capabilities to determine whether it's a social security card, or social security number, a credit card, or some sort of personally identifiable information. Let's see, other questions. Where in the hierarchy or network topology does this device software, Cisco Secure, work, both internal as well as external to the internet? How does it update the DNS database and caching for blacklisting and IP address purposes? So I think you're referring to as Cisco Umbrella, and Cisco Umbrella is being utilized by Cisco Secure Access, which is our hosted VPN service. Umbrella is essentially our DNS cloud. So what it's doing is you can utilize Umbrella on your own home PCs. You point your DNS to 208.67.222.222 or 208.67.220.220. That will tell us what you are interacting with via DNS requests. Of course, we're not doing any sort of packet capture. We get no additional information beyond that. But then we have enterprise customers who are utilizing this as a service. So they can say, here is my IP block, and here is everything that every IP that my users should be coming out of as they start to access the internet. Well, then I can get the intelligence within Umbrella to say, who is interacting with what resources from my company, and I can start to create an enforcement mechanism based on that. And then I have a set of categories, including anything from adult and violence all the way through streaming, social media, et cetera, that I can allow which aspects to allow for anything sourced from my IP blocks or not. So I use this at home. Essentially, I don't allow for any sort of violence, terrorism, anything that would be typical of not wanting it sourced from your IP addresses, while still allowing for plenty of other streaming services and social media, etc. Request for the slide deck. Yep, we'll gift these over to y'all. And where is Secure Web Gateway or Umbrella SIG sits the enforcement strategy point of view? I think I've already kind of talked about that a little bit. What is your recommendation or security controls in configuring Cisco Secure Access and protecting against brute force attacks? It doesn't really apply. Your firewalls are typically going to be your brute force attack mechanism, or Cisco's DDoS protection, which is in partnership with Radware. We typically do that in relation to some of our cloud services. Let's see. Yeah, I think I've answered all the questions that everybody has asked. So once again, I want to thank everybody for joining in here. This is a great turnout. I hope this was a great use of your time. We'll also be continuing the conversation, which I believe Carla will talk about, and the link that was just placed in the chat. But thank you, everybody, for attending.
Awesome. Thank you very much, Patrick. And as Patrick mentioned, yes, the link to where the post-event discussion thread. So if you do have any follow-up questions, please do go ahead and post it there. Do bookmark that page because it lists the previous sessions along with we'll actually be uploading a copy of the downloadable PDF of the slides today, along with the recording. I believe the live stream of today's session will be made available right after we end, so you can play that back immediately, and then the actual recorded, edited version will be posted 3 to 5 business days, and that link is in the chat. Once again, I want to thank everyone for joining us today. Your feedback is important. At this time, it will be directed to a survey, so we do encourage you to take the time to participate in that. Thank you again, everyone, and we will see you next time. Have a good day.